Alright, a couple things you want to review is our exponential growth. Remember, we're dealing with y equals ab to the x power. So growth is when that b value is greater than 1, so something like 1.5 to the x power. Decay is when b is less than 1, so y equals, we could do 1/3 to the x power, that would do it. Quadratic, remember that means we need anything with x squared, so we could do y equals 2x squared plus 5x minus 1, that would be fine. And linear, y equals 3x plus 1. So key here is we need x to the first power. Here I need x squared. And growth and decay we covered. Alright, moving on to the new stuff today. And it's really nothing new, it's just trying to identify, and that's our main focus here. Is we're talking about a linear function difference. Difference means that we're going to be subtracting, so that's what you're after. So the y values difference. When you subtract the y values, it's constant every time. We're going to do this twice now. So difference of the difference. If that happens to be constant, okay, just like here would be the slope. Now we're looking at the change of the change is constant. And we'll have an example of that. And y values have a common ratio. Okay, ratio means you're taking and dividing. So x over y. Some division equals r, a common ratio every time. That'll give me exponential. So you see another example of our linear. Here you see our quadratic. It goes up and down. Remember, this is the vertex. And over here, remember that we have our intercept here. It means it's going to go through 1, so that makes the a value here 1 based on this example. So a couple things that we'll review. We'll do more than what it says in the questions here. So if I want to graph them, 0, 0, 1, 1, negative 1 is at 1/2, and 2 is at 3. Well, just by looking at it, I see this growth. They don't line up at all, so it's not linear. So is it quadratic or exponential? So the next thing I'm going to do is take negative 1 and negative 1/2. So I'm just going to take these x and y values. 0 gives me 0, 1 gives me 1, and 2 gave me 3. So first difference is 1/2, 1 and 2. This is not common, so this is linear, question mark, and my answer is no, it's not linear. We threw that out. So difference of the difference. Now I have 1/2 and I have 1. These are not the same, so quadratic, question mark, my answer is no. This column is not the same, so it's not quadratic, so it must be exponential. And that's the process we go through. Okay, next thing we're going to do is fill these in. So check, got that one in the table. 0, 1, 1 pairs with 2, 2 pairs with 4, and 3 pairs with 8. So here's the next thing we're going to do. I'm looking at 1/2 as the change, 1 is the change, 2 is the change, and 4 is the change. Again, I'm going to change these colors out so you can see. Here's 1/2 is my difference, 1 is my difference, and 2 is my difference. So linear, no. Quadratic, no. It is exponential. Okay, so what's going on here is our change each time. So it looks like we are multiplying by 2, right? Because if I take 1 divided by 1/2, I get 2. If I take 2 divided by 1, I get 2. If I take 4 divided by 2, I get 2. And 8 divided by 4, I get 2. So a couple things that I can identify here. Y equals a is 1, because that's my y-intercept. And it's changing by 2, so 2 to the x power. So exponential and 1. And the ratio each time is 2. So that's how I'm getting my equation put together. Let's take a look at that again. So I look here, I have minus 24, I have minus 4.8, so it is not linear. That's out. And if I take the difference of the difference, that's not going to work. So it's not quadratic either. So it's going to be exponential again. So we'll take a look at trying to put these together just a little bit. And we do want to write an equation. So we do know it's exponential. So y equals that a value. I'm going to take that from my chart, so 6, and what's happening each time. So let's take a look at this. So 6 over 30, that's 1 over 5, or 1/5. 1.2 over 6 is 1/5, and 1/5, and 1/5. Okay, if we take care of our calculations, so that means I have 1/5 to the x power. Okay, so I do want to graph the set here, and then pick what is most appropriate. Okay, we're always going to be going back and forth between two different things. I'm graphing it and setting it into a table. So if I take my table first, negative 2, 0, negative 3, 3, negative 1, negative 1, 0, 0, and 1, 3. So I have 3. My difference is 2. My difference is 2, and my difference is 3. My difference here is 1. My difference that should be 1 here. So 3, 1, oops, that should be 1 again. Alright, so I got 2, 1 to a negative 1 is 2, and negative 1 to 3 is 2. Alright, so I just counted my 0 to negative 1 as 2 for some reason. So 1 and 1, so negative 1, so 2, 2, 2. So this is my linear check, and it becomes no. This is my quadratic check, and it's yes. And what we can do real quick is plot those points. 0, 0 I know was 1, negative 1 was one of them. Negative 2 was at 0. 1 is at 3, 1, 2, 3. And negative 3 was at 3. There's that quadratic. Okay, there's that parabola that we've been working with in this chapter. Remember axis of symmetry right down the middle. That's one thing we missed on the quiz. I'll get those back to you. Okay, they are in IC if you're concerned. So quadratic, and here's that column that we're talking about. The difference of the difference. Difference of the difference. Quadratic. Use differences or ratios. So the first thing I always want to check is just my differences first. So here's 4, difference is 4, difference is 4, difference is 4. It's linear. Alright, so let's check a couple things. So minus 3, here's my slope then, if this is linear. So 4x minus 3. We just built the equation. They didn't even ask for that. Look how smart you are. And so that's what we're taking a look at. Type of function. So here we're looking at 1/2. I'm looking at 1 and 1/2. I'm looking at 2 and 1/2. I'm looking at 3 and 1/2. Let's check the next set of differences is 1, 1, 1. So this is linear, question mark, no. This is quadratic, question mark, yes. This is quadratic. Okay, so we see that a little bit easier. We only have one side, so we don't see it go up and back down like we did in the previous example. But that should help out with that. Alright, and we get our real world example. So here's what we're talking about. So 0 is at 12, 18,254, 18,007. So we're getting close to that middle. Notice this is going by 2 grand, so I can't go the whole way up there. Just over 19. We're short of 20, and finally after 4 years we break over the 20,000. Okay, that might be a little bit high. Alright, so what we see here is circular is not one of our options, and we take a look at some of our differences. Okay, so 476, 485, 480, 480. Now here's the whole thing, right? Real world data. Alright, it's not going to go by this nice formula that you always have out of this textbook problem. So these are all hovering right around that 480, 485, 476. So these are out, right? It's not growing in that type of fashion. So we can come up with, maybe we would average these. I think what we'll do is we'll take the 480 and call that the slope, make that a 0. 480 and call that the slope. And here's my y-intercept. The first year that they had 18,254. So we can make a prediction, right? Maybe this small theater company, maybe what they want to do is add on. They want to try and add more space because they are growing in profit. So what we could do is use, since X is a year, say, hey, well, what about 10 years from now? 10 years from now, how much money do they expect to bring in that year? What about 50 years from now if it continues at this pace? And what can they do to drive that up? So only point here is that these numbers won't be exactly the same when we talk about real world data, because not in the real world are you going to get exact items. Alright, lesson check. I do want you to try these out. Okay, should have one of each if that helps, what we're trying to do here. take care of 4 and 5, and make sure you write down any extra questions, as we'll do a little bit of review for homework tonight.